Okay, so welcome to Lecture 9, Theory of Structure CEE 312, here at Catholic University of America, summer session. Let's pray, and then we go into a few reminders. In the name of the Father, Son, Holy Spirit, Amen. Director, Lord, we beseech you, our actions by holy inspirations, and carried on by grace assistance, that every prayer and work of ours may begin always from you, and through you come to completion through Christ our Lord. Amen. Father, Son, Holy Spirit. Amen. Okay, guys, a few things before I start. First of all, I'm trying to record this lecture uh, using another method that I found out. Okay, so kind of I'm using like today my second screen, so I have everybody here that's live and also the chat in my second screen. And before, like I used to share my iPad screen and my computer was always frozen. So let's see how it goes today. Okay, so sorry if something looks different or something like that. Second, okay, today is going to be the review. Let me open the review here. Okay, the review for the midterm exam. That's going to be on Wednesday. Okay, I already told you guys about the midterm, but quickly, once again, midterm Wednesday. You can take it anytime, but expect everybody to take it on Wednesday. It's going to be around 4 hours of exam. I mean, you're going to have 4 hours. It's not that you have to use the 4 hours or all the problems is going to be kind of 4 hours to solve it. No, some of the problems are going to be very straightforward, but I'm going to give you 4 hours to work on it. Okay, so today we're going to see some review here. I think I have 1, 2, 3, 4, and 5 questions here in the review, but pretty much what I'm going to cover is truss, shear moment diagram, and deflection. So pretty much 3 topics, okay? And how many questions? Yeah, probably is going to be 3 questions, okay? Probably is going to be 3 questions, or 3 or 4. Let's see how it's going to play out, okay? But more than 4, I'm not doing that, okay? So 3 or 4 questions covering the truss, covering shear moment diagram, and also covering deflection, okay? So expect 3 or 4 questions, mostly 4, but who knows, okay? So let's say 4 questions. So if it is 4 questions, it's going to be kind of 1 hour per questions, more than enough, okay? Just keep in mind, you need to start the tests before midnight, probably, so you're able to complete. You have those 4 hours. If you not submit, then after 4 hours, it will automatically submit it, whatever you are, okay, in the problems. Then don't forget to work on homework number 3, which is due Monday, okay? Hard deadline. And please, guys, submit the homework, okay? I have these not 1, 2, or 3. Many of you forgetting about submitting the homework, and then just send it late, okay? Please, it's hard deadline, okay? Hard deadline, because the other day, Tuesday morning, I'm posting the solution, so you have 1 day to review and 1 day to prepare. With that in mind, okay, Tuesday, we are not going to have class, okay? Tuesday, we're not going to meet, okay? We're not going to meet on Tuesday. Please take that time to review for the problems, to review things for the homework, to study a little bit more, okay? For the midterm. And on Wednesday is the test. And once again, we're not going to meet, okay? Don't expect me to come here 2:30 and wait for you to complete the exam, okay? It's going to be take whatever you want, whenever you want to take this exam, okay, on Wednesday. So we're not going to meet. And Thursday, probably I'm going to record a lecture and post it to you, okay? We're not going to meet again on Thursday. So next week, we're not going to meet on Zoom, okay? Probably I'm going to record a class and post to you. Why is that? Because I'm going to a conference. Okay, I'm going to a conference on Monday, and I will return Thursday. Okay, so that's why I'm going to record the class and also take the break for you to study for the midterm. All right. With that, if you need to meet with me, go over a few things next week, yeah, it's possible. Okay, but probably in the evening. Okay, I'll be in the conference, and probably late afternoon, evening, we can meet and we can go over a few things on Monday, on Tuesday. Okay, so just email me if you have any questions, and then we can communicate. And I think that's it. Okay, that's it. And then the following week we just start again the meeting here on Zoom. Sounds good? Any other questions before we start regarding the midterm? Okay. All right. So all good. Let's start. All right. So the midterm exam here, as I told you right now, just right now, I expect to cover truss, shear moment diagram, and of course shear moment diagram, beam and frame, and deflections, beam and frame. Okay, with that would be 1, 2, 3, 4, 5, kind of 5 topics. Okay, but I'm not gonna put 5 questions over there. So probably one of those is gonna be just frame, just beam. But please make yourself comfortable to solve any kind of problem. Okay, for the first problem that I have here to review with you, okay, is the truss problem. It's pretty much a common truss problem that we have. And for the exam, I'm going to give you not the opportunity, the choice to choose the method that you want. Okay, I'm not gonna ask specifically for the method of joints. I'm not gonna ask specifically for the method of sections. Okay, what I want from you is to solve the problem. Which method you're gonna pick, that's up to you. Okay, with that, I will solve this problem here using the method of section, and then at the last one, I'm gonna solve using the method of joint. Okay, the last joint here, the last member. All right, so I can cover both, and also the section is a little bit tricky, or sometimes people like it, but it's confused about the moment. Okay, so I'll do that in the review. Okay, but it's not, again, it's not I'm not saying that you have to solve using section only. No, you can solve a joint, you can solve by section, or you can solve it combined. Okay, depending how you like. Sounds good. So first question, we need to find the force in the members. Let me take my pen. Okay, it's working. DE. So this is the member. CD and AC, and also AB. All right, so I need to find the force on those 3 members. Okay, 4 members in this case, 4 members, and state if they are in compression or tension. Okay, I have 30 kilonewtons on the top, 25, 50 kilonewtons over there, and have this triangle here that's going to help me find the angle probably. And I think that's it. Okay, so looking here, for example, for the method of section, what I need in order to solve the method of section? Well, what I need is 3 members. Okay, I need to make the cut through 3 members in section. Why? Because section, I have 3 equations. Sum of the force in X, sum of the force in Y, sum of the moments. Okay, 3 equations. I'm gonna cut in 3 members. So this 1, 2, and I'm gonna go outside. Okay, so always I need to start from one side and go to the other side. So my cut probably would be this one here. Okay, probably would be this one. Of course, I can do it. Can I do a cut like this? Yes, But if I do a cut like this, it's going to be kind of a joint because I'm going to have just those three. Okay, it's going to be kind of a joint. So just joint method. Okay, Bruno, can I start joint? Yes. Okay, how you pick your first joint to start? You need to pick a joint that has up to two unknowns, meaning two members that you don't know. For example, can you start, okay, a joint A? Can you start a joint A? Well, we don't know AC, you don't know AD, you don't know AB. Three members. So do not start at joint A. Should I start in joint B to find already AB? Yeah, that's good. I have two unknowns. Okay. What about C? Well, one, two, three. No. What about D? One, two, three, four. No. And what about E? One, two. Yes. So here, okay, if I have to solve for everything, of course, because I'm asking for a few of them, maybe we need to figure it out which one going to start. But E or B looks good for joints. For section, the cut's here with respect to those three members that I want to find. Okay, and that's what I'm going to do. Okay, as I said, I'm going to use the section first. So this is section A. Okay, this section AA, that's the section I'm going to cut and find my answers. Okay, so I'll find first DE, CD, and AC. Later, I'll solve AB. All good? What's the first step that we need to do in order to start this problem? Well, the first step always is the reactions. The reactions. But I don't know if I mentioned this here in this class or not, or last year. Okay. Once we make this cut, take a look. We're going to make this cut. We need to select or this side or that side. Okay. For example, if I make this cut and select this side here, does the top side, does it have any reaction, any support? No. No. I just have this part, this part here. Okay, this one right here. I have 50, 25, and 30, and that's it. Now, if I select the bottom part, meaning this section here, what I have, reaction A, reaction B, support A, support B. The section sometimes is good because of that. For example, for this problem here, we can select the top and skip the calculation of reactions. We can skip it because once you select the top, we don't need the reactions. And that's what I'm going to do, okay? That's what I'm going to do. I'm going to select this one here. So I'm going to have E here and up to here at C, okay? And I made a cut, and cut, okay? However, this cut right here, okay? Let me just extend it so I can use those points if needed, okay? If needed, I can use those points right here. All right. I think it was too much. Should I delete this? It's narrow here. Looks better. All right. Once I do that, this is my FD. This is my FCD. And this is my FAC. Okay. I cannot forget about the external force, 30 kilonewtons, 25 kilonewtons, 50 kilonewtons. Okay, just to, so this is E, this is D, this is C, and this is A if needed. All right, so that's what it is after uh, the cut. Let's just figure it out really quickly here. This angle, okay, this angle here, let's say angle theta. What is going to be this angle theta? Well, by similar triangles that we have here, this angle, do you agree that's the same as this angle here? As I agree. So this is the triangle. This is inverted. Okay. Well, there are many ways we can think about this as another triangle here. Okay, where this is the same pink angle and this is just the opposite. So the same pink angle. Okay, pink angle. And also, if you have that one, the orange here is going to be this same orange there. Say alpha. Okay. And here we have many ways to solve it. Okay. You know, the most common way that I like to solve this, it was like theta was tangent minus 1 of 5 divided by 12. Okay. Opposite, adjacent. Okay. Or sine, cosine. Okay. These would be, here I solve it 22.62. Okay. However, there is another way. I want to mention, probably I'm going to solve it by this way. For theta, okay, for theta, for example, what is the sine of theta? Sine of theta using this triangle here, what is sine? Sokatoa, opposite. What is the opposite? 5. What is the hypotenuse? 13. Cosine, 12, 13. Okay? So we can use this fraction already in order to, instead of using the angle 22.62. Okay, because let's just make sure. Okay, sine of 22.62, 0.38. 0.38. 5 divided by 13, 0.38. Okay, so exactly the same. So here, presenting two options for you. Okay, using the angle or using already the value of sine, the value of cosine. Okay, coming from this triangle. So it's up to you. Choose the method that you want. Okay, because I always use this one, let me use this one today first. Okay, because I see a few students doing it as well. All right, so after figuring out the angles, okay, after figuring out the angles, of course I need to put something here. Okay, for the other one. And alpha is what? Tangent minus 1. If you're gonna do it, the opposite, right? The opposite is 12 over 5. This is 6, 7, 38. Okay, or opposite, sine of alpha, 12 over 13, cosine of alpha, 5 over 13. Okay, in case you need. Okay, enough of that. Let's jump to the method. Okay, Metal section, I need to choose one point here, okay, in order to solve it. For example, if I do the sum of the force in X, I will have FCD, but I also have this component, FDE. Sum of the force in Y, I'm going to have this component and also FAC as a known. But what about moment? Can I choose one point where two moments are going to cancel and I can get one answer? Well, I see here two options. Moment about, actually more than two, more than two. I see three options. Okay. You can take the moment, for example, a moment about E. This will not cause moment. This no moment, this no moment. This one, no moment. What are you gonna have? This and this. Why FAC is not moment over there? Line of action. Look. If I choose C, no moment, no moment, no moment, no moment, line of action. This one, this component, moment, but this other component, no moment. I can find here FDE. Oh, so great. How about D? No moment, no moment, no moment. I will have this, this, and this. I can find FAC. See? 3 points, just of moments, I can already finish the problem. Really quickly. Okay, at least these three members, not the problem, but these three members, I still have AB. Okay, so I don't know which one you want to take. E, C, or D. Okay, I don't know. Some of the moments about what is Cindy saying E. You want to cancel everything, Cindy? Okay, let's do that. Great. Some of the moments about E equal to 0. Okay. What do we have? Study doing any moment about E? No. Line of action, passing to the point. 25? No. FDE? No. Okay, passing to the point. FAC? No. Line of action, passing through the point. Now I just have 50 and FCD. So what I have is 50 kilonewtons times, what is this distance? Okay, 6 meters. And it's going to be a positive or negative moment. Is there positive moment? Positive moment. What about FCD? Well, FCD is just the same direction, just doing the same thing here. So FCD 6 equal to 0. What do we have, guys? FCD negative 50 kilonewtons. Kilonewtons, yes. You guys agree with me? Okay, the 6 is going to cancel, go to the other side, negative 50. We found another one. Found the first one, actually. Okay. So having FCD now, we can still go for another moment, okay, as we discussed before, all right? Or we can go for sum of the force for the same, sum of the force and X, because now FCD that was unknown is not an unknown anymore. Okay. Let's do that. Just to change sum of the force in X. Sum of the force in X should be 0. What do we have in X? Positive 25. Positive 50. FDE. FDE. What is this? Sine or cosine? Right here. The angle is there. This is sine theta. This is cosine theta. Horizontal force is the sine. So plus FDE sine theta and FCD, which is, okay, following my drawing, FCD is positive, so positive. But what is the value of FCD? Negative 50. Okay, so these two cancel, okay, those two cancel, 50 and 50, negative, positive. What I have is FDE, FDE. What is sine? I can do sine of 22.62, or I can come here and say the sine is 5 over 13, negative 25. FDE is going to be 25 times 13 divided by 5. This is 65 kilonewtons. Okay, I forgot. Let's do this right now. Okay, negative means compression. Negative means compression. So far, so good, guys. Any other questions? Any questions at all? No? Then let's finalize with sum of the force in Y. Sum of the force in Y should be 0. We have negative 30. Okay, negative 30. What is this? FDE. FDE negative, negative FDE cosine, and negative FAC. That's it? Yes. 0. What do we have? Negative 30. Negative, what is FDE? FDE is negative, so negative 65. Cosine, what is the cosine of theta? I have over there 12, 13. Okay, or you can write cosine of 22.62 minus FAC. Okay, so right here, FAC, go to the other side, positive. FAC, right here. FAC, go to the other side, positive. So I have 65 times 12 divided by 13 minus 30. This is 30, positive 30. 30 kilonewtons. And what I know is tension because it's positive. Okay, then that's it. Really straightforward. I got 3 members. 1, 2, and 3. All right. Of course, I'm missing AB. AB. Now for AB, I can make a cut here or work with joint A or joint B. Okay, because I already know this one here. So I have 1 and 2 unknowns. And for this one, I have 1 and 2 unknowns. However, guys, okay, I skip calculating the support reactions. And right here, we need the support reactions. And neither of those points. Okay, we need support reactions. Okay, Cindy say, let's do A. Okay, no problem. Okay, let's do A. But before that, we need to calculate, if we're going to do A, we need to calculate what? AY. Okay, because this is what I have in A. And in order to do that, okay, can I do for the whole structure? entire structure. I'll do some of the moments about B. Bruno, why is some of the moments about B? So I can cancel this by. I can cancel this by and do just ay. Okay. And sorry, I also forget. I almost forgot. Oh my goodness. That is this one here. AX. AX. Okay, because this is a pin support. It is a roller support. Okay. So I need to find both actually. I need to find both. AX is straightforward. AX actually I can do that. Okay. For the entire structure. So before that, let me do this AX. For the entire structure, sum of the force in X, it's equals 0. What I have? 25, 50, AX. AX should be negative 75 kilonewtons. Okay, meaning it's going to the other side. Okay, so AX, all good. So let me go back to some of the moments about B. So I can find AY. Okay, one by one. Let's go with me. Is BY doing any moment? No. So that's why I choose B to cancel BY. Is AX doing any moment? No. Passing through B. Is AY doing any moment? Yes. Clockwise. So negative AY times 5. Is 50 doing any moment? Yes. Clockwise. What is the distance? To B, 6. Negative 50 times 6. Is 25? Yes. Line of action. All the way there. 12. Clockwise. Negative 25 times 12. And the last one, 30. 30. Yes. 5. 30 times 5. Counterclockwise. Positive. Okay. How much is it? Let's see. EY go to the other side positive, so negative 50 times 6 minus 25 times 12 plus 30 times 5. 450 divided by 5, negative 90 kilonewtons. Negative. See if you can get it. Okay. So both of them, AX and AY, are negative. Okay. All right. My last one here. Okay. Since said let's go joint A, so that's why I did all of those to go for joint A. And for joint A, I'm gonna have the following. See if you agree. Force AB. Force, which force is that? Force CD. ACD. No, sorry. AC. AD. Oh my goodness, AD. And then AC is this one here, AC. And I also have AX, AY. Now, guys, I have two ways to solve this joint that I have already many knowns. For example, FAC is 30 kilonewtons. Tension, meaning, is leaving this joint, which it is what I put here. So this is good. FAD, I don't know. This one, let me put it right here, 30. FAD, I don't know. FAB, I also don't know. But AX and AY, I know. And pay attention now, pay attention. AX and AY, I chose them to be like this. Okay? That's how, my goodness. That's how I'm putting here, right here. AX going to the right, AY going up. However, I got the negative. Okay? I have the choice to keep this same way here and keep the negatives, or I just flip this to that side and down and get rid of negatives. Okay? Because those negatives just mean that the direction that I draw, it was wrong. Okay? It's going to the other direction. So it's up to you. Okay? It's up to you. Sometimes I flipped it and students get confused, so I'm gonna keep this and use the negatives. Okay? I'm gonna keep the same and use the negatives. Okay? But keep in mind that you can flip this and get rid of negatives. All right, with that, let's finish this problem. Okay, already took so long. FAC, I know. AY, I don't, I know. Okay, so this for me is going to be negative 90, and this for me is going to be negative 75. Okay, so no. I don't know. What I'm looking is FAB, but FAB is X. If I start with X, guys, I know, I don't know. However, there is a component here that I don't know as well. So it's not going to go anywhere. Okay. So what I'm going to do, I'm going to start with Y. Okay. Let me skip one step here. Let's start with Y. Why, Bruno? Because I know. The only one that I don't know is FAD. Bruno, but I don't want to know FAD. Well, sorry, but we need to know FAD in order to find FAB. Okay. So what I have going up, 30. Going up, AY, positive AY. I'm not talking about flipping this 90, okay? 90 is still negative. I'm going to put the negative here in a moment, okay? And then FAD plus FAD, oh, sine or cosine now? Of what? Of what? What about now? What about now, guys? Okay, what should be that angle? Well, we can figure it out. How, Bruno? You can take this triangle here, okay? Few ways. This triangle for this angle here is going to be tangent of 6 over 2.5. Tangent of 6 and 2.5. Or you can think about what you already discovered. Guys, this one right here is our alpha. Same inclination. This one here is alpha. If this is alpha, this will be alpha as well. because we can split it here. Alpha and alpha. How I'm sure? Well, I just said tangent of 6 divided by 3.5. 6, 3.5. Guys, take a look. 12 over 5. Oh, this is not the same as 6, 3.5 divided by 2. Okay? So this angle is 6, 7, 38. 6, 7, 38, this angle alpha. So this is going to be, okay, FAD, angle alpha here, is right here. I'm talking about the y-axis, so it's going to be sine of alpha equal to 0. So this is, okay, 30, negative 90 plus FAD. What is sine of alpha using that one? Sine of alpha, 12, 13. 12, 13 equal to 0. How much is it, guys? Let me see really quickly here. If it is this side, so the other side go 90 minus 30, 60 times 13 divided by 12. What I have is 6.5. FAD, positive 6.5 kilonewtons. Okay? And then with that, I can finish right now my problem finally. Okay? AX going to the right, positive, plus FAB, positive, plus FAD, cosine of alpha, positive. But I know AX is negative 75. FAB, I don't know, I want to find. FAD is positive 6.5, cosine, that is cosine of alpha, then is 5 over 13, if I'm not wrong, should be 0. That's it? Yes. At the end, FAB is going to be what? 75. Oh, sorry. 6.5 times 5 divided by 13. That's 25. Go to the other side. 75 minus 25, 50. FAB is going to be 50 kilonewtons. Positive, so it's a tension. Woo! Finally. Took so long. Any questions? Okay. This one was a good problem. A lot of assumptions, 2 angles. That was awesome. It's great. Section, joint, reaction, no reaction, back and forth. All good, guys? Any questions? You have the opportunity to ask questions as well at the end of the class, okay? For homework questions or whatever. All right, so let's keep going. What time is it? Ooh, it took so long. I'll do much faster for those next one, okay? Just because trust is just a lot of going back and forth. And this was a long problem because I chose 4 sections, 4 members, just to show you different stuff. All right. Shear moment diagram for this cantilever beam, actually, is the cantilever and overhanging beam, actually, because we have this roller support and we have a hinge as well over there. How we deal with hinge. Okay, are you guys ready? Starting the problem, not wasting time anymore. So this one, AEY, MA, AX, 20 times 10, right here in the middle, I have 20 times 10, 200 kilonewtons, okay, at 5 meters if needed. And that's it before I start the problem. Okay, let me do here. Sum the force in X should be 0, straight for AX 0. All right. Sum the force and y should be 0. I have ay positive, negative 200. Almost forgot about this one. It's called what? by. Ay positive, negative 200, positive by, negative 100. Okay. I don't have anywhere to go. Ay plus by should be 300. Now, guys, if I choose the moment about A, we have by and also ma. Okay. So probably every single time that we have the hinge, the best is for us to start doing moment about hinge. And then for the hinge, you have options coming from the left or coming to the right, coming from the right. If I come to the left, okay, I will have MA and AY, so two unknowns. It's not gonna help me, okay? But if I come to from the right, there's a known, known, and just one unknown, okay? It's gonna help me. So that's what I'm gonna do. Some of the moments about hinge coming from the right should be 0. What am I gonna get? Take a look. 100. And take a look. We are talking about hinge. Pay attention. Okay? 100 times 15. Clockwise, negative. By, counterclockwise, 10. 200 clockwise, negative times 5 equal to 0. So I can find by. Okay? In my notes here, I have by as, let me see, I have by 250. With that, can I come back here and solve this? AY, so by 250 goes to the other side. AY is going to be 50 kilonewtons. If I have by, if I have AY, what I'm missing, MA. Now I can do moment about A, I can do moment about any other moment about B, but I also can just straightforward here, just because to work once again, hinge coming from the left should be 0. Hinge coming from the left, I have AY negative 50 times 10, and I have positive MA. Well, very simple, MA 500 kilonewton meters. Okay, so again, when we talk about some of the moments about a point, excluding the hinge, we talk about the moment, every single force in the entire structure. Now, when you're talking about the hinge, okay, the moment about that point should be 0. Okay, the moment, the internal moment about that point, the internal moment. And when we are talking about internal moment, we're coming from the left to the point or from right to the point. Okay, we don't do the entire structure for the hinge. Sounds good? Okay. Okay, now with my reactions, all of them positives, I can do the shear moment diagram really quickly here. Okay. Let me see what I can do from here to here somehow. It's okay? Yes. Shear, kilonewtons. Okay. And then maybe I can already draw the moment line to their moment kilonewton meters. Okay, so let me put it like this. We start shear. Shear 90 degrees should have been, or to the structure, to the member. AY is doing shear. Okay, coming from the left, going from left to right. I can go just up and down. AY is going up, 50 going up. So right here, 50 going up. Then from A to hinge, I don't have anything. Just a straight line, 50. When I start the hinge, I have this distributed force that at the end should go down to 100. So if I have 50 minus 200, it's going to be negative 150. Okay, so negative 150 should go because distributed force should go all the way here. I'm going to guess here. Okay, and this is negative 150. When I get to negative 150, I have By. By 250. So I go all the way back again to 100. Maybe 100. 100. Okay. And then I keep going to here. Then I go back to 0. Sounds good? With that, this is 1 point. This one is going to be 1 point of change. This one has to be one of those. This one here as well. And this one, of course, right there. Okay. So before I move, I need to find this x here. And that x is going to be what? The peak, 50, divided by the slope, 20. This is 3.5. This is 3.5. This one here is 7.5. Now I can just zoom here so you can see better. Okay, guys, I will skip like the calculation for the area just to save some time. I'm gonna do my calculator here. Okay. So we start actually. Sorry, I zoom it, but we cannot forget that we have the moment. Okay, we have a concentrate moment here. We have a concentrate moment. Remember, concentrate moment for the moment diagram is, you have to think about, if it's counterclockwise, it's gonna go down. Okay, counterclockwise is gonna push it down. It's gonna be an internal negative moment. Internal negative moment. So this one here is, no, all the way to here is enough. Probably negative 500. Okay, so we start with negative 500, and the only time that we start with some moment is when we have this concentrate moment, cantilever beam. Okay, so pay attention. This one here is going to be 50 times 10. It's going to be positive 500, which is what I was expecting, because now this moment go to 0. And why this moment has to go to 0? Because we have the hinge, guys. If I have the hinge, this moment right here should be 0. So if at the end you come here and you don't get 0, okay, you're missing something. You're missing something. Something is wrong. Okay, something is wrong. Okay, so straight line, slope, then here to there, and here to here is going to be a curved line. Okay, curved line. So let's see, 50 times 2.5 divided by 2, 62.2, 62.5. So right here is going to be positive 62.5. This one is 7.5 times 150 divided by 2. This 562.5 minus 2.5, 500. Gonna go all the way back to 500. So right here to here, going all the way back to here, 500, negative 500. And then 500, 100 times 5, 500, so go back to 0. And it's going to be straight because of that line. This shear 50, this is slope 0. So right here I have to come like this, kind of straight line, and leave like a straight line. So it's pretty much, this is kind of a parabola, kind of like the... And that's it. Shear moment diagram for problem number 2. Much faster. Okay, maybe what I solved, what, 10 minutes, 15 minutes. All right. Any questions? What I just did? Shear moment diagram, all good? Okay. So let me keep going because I don't want to leave you it out solving the review. Okay, let's talk about frames. Okay. Draw the shear moment diagram for this for each frame. Okay. Okay, I think this is a specific one. I didn't solve something like that in class. But let's see. Okay. I have 45 reactions. AY, AX, CY. It is. Ooh, do it correctly. Right here. How much should be it? That's the question. I don't know. Why? Because it's 3 times this length. I don't have this length. I need to find, because this is 10, this is 15. Okay, I don't have this length, but I can find. Okay, I can find. So the first thing here, I need to find this length. Okay, so let me put this triangle right there. This is length F, this is 15, this is 10. Clear how we can solve it? L, square root of 10 plus 15 square. L is, how much is it? 10 square plus 15 square, square root 1803. What is it? Feet. Okay. So how much is going to be this one here? 3 times 1803. This is going to be 54 times 09 in this case. Kips. Okay. Now, if we start the sum of the force in x, sum of the force in y, what's going to happen? Well, in any case, we need to find the x and y of this one. Okay. So now we need to find this and this. Okay, but now I need an angle. How can I find an angle of this, of that one there? Okay. How can I find this angle? Remember the representation? Let me do the representation, the visual representation here for you. Once again, I think the best way to visualize. X, Y, and I have my bean here. We are talking about that bean. So I can show it here once again. Let's bring a back or pink angle. Theta. Where is this theta? Why this? This is theta. That is theta. This is theta. This one right here is theta. Where is my force? My force is like this, inclined like this. You guys see? Force inclined like this. The 5409. So my angle is together with what? Vector and y. So this right here is theta. Okay? That right there is theta. Now I can say that this is 5409 cosine and this is 5409 sine. All right, now I can start my problem. Now I can start my problem. Okay? Sum of the force in x should be 0. Ax positive, negative 5409. Oh, sine of theta, sine theta should be 0. Ax should be, what is 5409 sine of, what is this angle? Oh, I didn't find the angle, guys. Come on, please, let me know. I was forgetting the angle. Tangent -1. What is this angle here? Which is this angle here, okay? 15/10. What is this? Tangent 15/10. 56. 31. Now, going back here, 5409 sine of 56/31. 45. 45 k's. Okay? Sum the force in y. So I could skip this one because I don't know. Okay, I don't know ay. I don't know cy. I have to just put it here. Ay plus cy is going to be what it is. 15409 cosine of 50/31. 30. This is 30. That's it. 30. 30 plus 45. 75. Sum the moments about A. Should be A, yeah. A or B, A or C, all good. So the moment about A, what do we have? 45 counterclockwise times 10. Negative 45 times 10. What else? What is this, guys? The moment, yes. Clockwise, negative. And what else? Well, this is, what is the distance? This is right in the half of it, right? So 10, 10, 5, 25. Okay, this is half of it, so it's half of this distance and half of this distance. Okay, so this is going to be here negative 5409 cosine times 25. Okay, and then I have negative 5409 sine times 7.5, half of 15, plus cy times 30. Okay, by my calculation here, let me skip this one. This one I have cy, where should I put it here? Here, cy equal to 51.25, and ay is 23.75. Okay, then let's start the shear diagram. Shear diagram. Okay, shear diagram. Actually, let me do like this. That is the shear. AY going up. AY 23.75. Then halfway we have 23.75 minus 45, 21. 21.25. Now, this one here, okay, a little bit tricky. What's the shift for this point? Now it start as the reactions for all of those. Those are action. Right here is going to be a reaction to all of those. Okay? Okay? And what are those? And also incline. Take a look at this joint. Okay? That joint right here. Okay, B, this is B. I have, take a look, reaction to 45. And 45 is coming here. And then I have this one here. The 45 as well. And I have this AY 23.75. Okay, 23.75. What I'm going to have, and I mean, I want to know the shear with this guy here, incline. So I need to make those incline, meaning I need to find this component, okay, that component, and this other component. What's going to be those? You can also already put them together here. 45, 23, 75 is going to be the 21, 25 going down instead of doing both. Let's do both here. Okay. What's the angle? Just take a look here. Hey guys, take a look here. This representation. So that's why it's good. 45 going down. I need this one here. So this one is what? 45 cosine. 45 going this one here. I need that one. Okay. Well, this one here, no, sine. So what is it? 45 sine Once again, I have this one here, and I need that one here. That is cosine. 2375 cosine. So those three components is going to be the shear on that point. Okay. And if you calculate, what I have here is, put it here, 2565. Okay. So those are the resultant here. Okay. Let me see. Negative 45 cosine of 5631. Positive 45 sine of 5631. Plus 2375 cosine of 5631. Yeah, that's it. 2565. Okay, and of course, this is going down, negative, this is going up, positive. Okay. With that in mind, I should decrease from here to there. How much? Well, this is already inclined. Take a look. All good. Awesome. I should decrease 54. Okay, all of these. I don't need to worry about the components because these are already inclined. So this one, 2565 minus 5409 is going to be 28. So right here, negative 2844. Okay. And luckily, I will trust myself. And if I have to do this component CY, okay, meaning this one here is going to be the CY cosine 51 cosine of this angle, I have to get 28. Okay. Ooh. Okay. Those inclines always take some time. Moment. Okay, let's finalize this. Moment. Here and there. Okay. Moment. This area. 23 times, yeah, times 10. This one here is going to be 237.5. Then 237.5 minus 21, 212.5 is going to be 25. So this one here, 25. Doesn't care if it's inclined for the moment. If we have 25, it's going to be 25 here. Okay. Then I'm going to calculate those areas. Okay. Then I need to calculate that X here. Okay. I'm missing this. I already put the X somewhere. No. So this is going to be X. What is this X? X is 2565 divided by the slope. What is the slope? 3. Okay, that's the slope already inclined. 3. So X is, my calculation, 8.55. Okay. Calculate that area. Okay. You're going to go up to, going to go up here to 134.76. Then you're going to close at 0. Okay. Slope 0 and then go all the way like this. Okay. Very straightforward here at the end. Okay, just calculate those areas. So I'm skipping calculating the areas here, just giving the solution. So that's the easy part, calculate the areas. If I can tell you before I move to the deflections, something about those problems, okay? Know how to calculate this X, okay? What I'm doing, take the peak and looking here for the slope, okay? Because we did this here as well. All right, what else? Know how to do this, especially if you have a frame for shear moment diagram here or for the deflection in a moment. Okay, know how to deal with it. Remember, moment that finish is the moment that start, but this does not happen with the shear. Okay, shear you have to find the component. Okay, and see if other force like this AX is doing shear on this member, but it's not completely the AX, it's the component of AX. Okay, so that's it what I for shear moment diagram. All right, times it. Okay. Ooh, this is going to be straightforward. I have two deflection problems that is straightforward. It's not complicated. Okay, so I can discuss just one thing that I want to show for you on the table. All right, and assume EI is constant. Okay, for this one, let's jump to it quickly. AY, AX, MA. Okay, sum of the force in X, AX0. Sum of the force in Y, AY 60. Sum of the moments about A. Okay, you're gonna fit 30 times 2, 30 times 4. So 60 and 112. MA is gonna be 180 kilonewton meters. Okay, I'm going straight for it. I'm not gonna keep writing things here, but please show your steps. What are you doing? Okay, every single time. Shear. Okay, so this is real. Shear, AY, 60. Half of it, 30. Then the other half, 0. Moment, counterclockwise, but the internal moment is going to be negative. So negative 180. That one, this is 60 times 2, 120. So 120, yes. So this is right here in the middle, 9 somewhere there. This is going to be negative 60. Then negative 60 with this one here is going to be 0. Okay, that's my real moment. This is kilonewtons, of course. Okay, keep the units, show the steps. Okay, write down that's the real moment, write down that's the real, and then you're gonna go for the virtual case. It's asking for deflection at point C. Point C is right here, okay. Deflection at point C. Keep the same structure. Remove all the loads. Add the load, the direction of the deflection that you want. Okay, I will assume this is going down. So what I have, AY prime, AX prime, MA prime. Sum the force in X, AX prime 0. Sum the force in Y, AY prime 1. Sum the moments, well, A, 1 times 4, MA prime is 4. Okay, that in mind, shear, moment, shear virtual, moment virtual, shear, go up 1, all the way 1. Positive 4, start here negative 4, 4, 1 times 4, that's the area of the shear, right here, 0. Okay, guys, now it's just table. EI, deflection C. What I have? Take a look at the moments. Well, here I have discontinuity. So pretty much I have this shape here, trapezoid, and this triangle. So what I need to do is find another shape here. Okay, I need to split these because they need to be the same, 2 meters and 2 meters, 2 meters, 2 meters. Now this is a straight triangle. If I cut this in half, it's going to be -2. So now I'm going to compare this trapezoid green with another trapezoid and a triangle with another triangle. Okay? 2 meters, right? So this is 180, 60. This is -4, 2 plus 60, 2 meters, -2, 2 meters. Let's find the equations. Trapezoid, trapezoid. Okay. Trapezoid, trapezoid, right here, guys. Trapezoid, trapezoid. So remember, for the trapezoid, doesn't matter if they are flipped or not. Trapezoid, trapezoid, there is no problem. Okay. The problem is when we start working with triangles or the shapes that are almost a triangle, like a parabola, like this, or a parabola like that. Okay. Trapezoid doesn't matter. Okay. So right here is this equation here. So that's what I want to emphasize to you. If you get a trapezoid, trapezoid, the equation is big. So pay attention what you're doing, okay? Pay attention what you're doing, all right? Can I copy only this part here? Let me see if I can copy this. Copy it. Let me see if I can paste. Paste. Oh yeah, nice. Okay. Right here. Okay. So this is going to be the following. Q is my M prime. So this is going to be what? L. L is 2. So 2 over 6. Okay. Q, -4. Parentheses, 2. MA, -180. Plus -60. Plus QB. QB is -2. M2. So input plus 2. And then parentheses, MA. MA is 180 plus 2 times 60. Did I close all the parentheses? Yes. So take a look. This is a mess. Okay. So please take our time solving this in the calculator one by one. Okay. What do we have to multiply here? Okay. We solve this one inside first, then multiply by my -2. We that was my bad here actually. So this one here I'm missing a parenthesis. This is 2 times. No, it's not. So just 2 times this plus that, okay? But I'm missing this. Oh, okay. That's what I'm missing, okay? This one here. Okay. Okay. This one with that one, and this one with this one. It's a lot of parents. This one with this, and this one with that. Ooh. Okay. Sounds good. Try to type it. Then the last one plus That one there, triangle, triangle is easy. Okay, the same side, LMQ divided by 3. LMQ divided by 3. L, M, Q, 3. At the end, okay, that should be the answer. So pay attention on those trapezoids. Okay, do it part by part. Okay, so not a difficult problem, just much straightforward than the others. Okay, at least the shear moment diagram. Let's go for the frame, and then we finish, and then you can ask questions regarding anything. Okay, here I just want the slope at point C. A slope at point C, A is fixed. Incline frame once again. Starting here really quickly. AY, AX. Actually, MA. 2 times 12. Right here at the middle. 2 times 12, 24. Okay. With this as 6. What else? Let me already do like the representation here. Pink angle. Theta. 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 Okay. Just in case I will need. Sum of the force in X, 0, AX, 0. Sum of the force in Y, AY plus 24. Sorry, negative 24. AY is positive 24. Keeps. Sum the moments about A. AX, AY, no. MA is positive, counterclockwise. And then this one is going to be negative 24 times. 24 times. I know somewhere there, the screen will watch me, just screen like times 6, which is not times 6. Okay? Is not times 6. Why, Bruno? I see 6 here. Yeah, but 24, 2 point A. This is not 6. 6 is just a part of it. Okay? Up to here, 6. We are missing something. We are missing this part here. Okay? There's a catch. Always a catch. Okay? Can we find how much is that? Can we find how much is this part here? Let's call this X. What about if we do like a triangle? This is 10. This is X. This is alpha or theta. What do we have? Cosine theta. Gsen tenus X is cosine of 60. Cosine of 60 is half. Yes, half. Half. Half times 10. 5. So 10 cosine 60 is 5. So how much is 24 times what? 24 times 11. Okay? So pay attention in the details. See? All right, so found the reactions. Shear moment diagram. Shear moment diagram. Okay. Shear. Now I start those kind of things, working with components. Why? Because shear is AY doing shear. Yes, but not all AY. Its component is AX doing shear. Yes, but not its totally AX. It's just its component is doing shear. Okay. Is moment doing shear? No. So moment, no shear. So we need to find the components of those two. But of course, okay, before you tell me something, of course, AX here is 0. Okay, so we can cancel, we can forget about this AX. AX is 0. Okay, so let's worry just about AI. But sometimes AX is not going to be 0, and then you have to consider. So that's why I'm telling you. Okay, but AY here is not 0. So AY, if you bring to here, AY right there, its component that's going to cause shear is this one here, which is going to be AY cosine of 60. Okay, so right here, its component is AY cosine of 60. Cosine of 60, we know that's half. AY is 24, 24 times half, 12. Okay, no shear, no shear, no shear, no shear, no shear, no shear. We trust ourselves and go back to 0. And then right here, we bring all those force up to this point, okay, because this is going to cause shear on this beam. It's going to be AY, so it's going to be 24 up. Then we have 24 going down. Very good. Boom. M, counterclockwise, but the internal moment is going to push down. Sad face, so this is going to be negative 264. And then this area here, 12 times 10. Why 10? Because this is the length. Okay, this is the length. 110, 120, 120 positive, and 264 is going to be, sorry, right here, negative 144. Negative 144. Remember, moment, rigid joint. This one here is also 144. So this one there, 144. Then 24 times 12 is 144. Then going back to 0, this incline, so it go as a curve, oh, like this. Okay, Why is like that? Because right here I have 0, so I have to come to this point like a straight line, okay, with slope as 0. Where's my space? Okay. Virtual case. Okay, give more minutes, few more minutes. I'll finish this one, guys. Almost there. One kilonewton, not one kip, sorry. AY 0, AX 0, MA 1 to counter that one that I'm putting in the system. Okay. Can I do it here really quickly? Shear. I don't have shear. AX and Y 0, so 0, 0. Moment. This one I start -1. Go all the way there, -1. Start as -1, all the way there, back to 0. Okay, very simple, the virtual one. Very simple. So what I'm going to compare, use the colors again, green rectangle and green trapezoid. And this is a parabola and rectangle. Okay, EI, rotation, trapezoid, 264, 10, 144, rectangle -1, plus this parabola -144 of 12, then -1, -1. Let's go to the tables and find trapezoid and rectangle. Trapezoid and rectangle right here. LQ divided by 2, MAMB. So this one here is going to be L, 10. L, 10. Q, -1. -264. 7. Plus -144. Divided by 2. Plus parabola in rectangle. So it doesn't matter the side. With rectangle is LMQ divided by 3. L 144 minus 1, 3. And then, guys, the answer should be this one here. Woo. And that's it. Okay. So those are the kind of problems that we can find in the midterm. Okay. Deflection, let's go again. Deflections, frames, and deflection beams. Diagrams for frames, diagrams for beams, especially with hints. Okay. And a review of truss. And you can pick joint or section. Okay, so stud 1. Okay, the one that you like the most. Sounds good. Okay. So before I go, okay, I will stop the recording, and then for those who are here watching live, you can stay a little bit more and ask me questions off the camera. Okay, off camera. And for you that are watching this later, okay, once again, let me know if you have any questions. Work on homework number 3, so you get ready for the test. Okay, review the homeworks. Okay, submit your homework. So you check out the solution on Tuesday. Okay, let me know if you have any questions. Okay, please be patient. Remember, I'll be traveling or starting Monday, so we can still talk late on the evening. But as soon as possible, I will reply you back. And at the day, okay, bring everything that you have. Sit down for 4 hours, 2 hours, up to 4 hours. Prepare yourself. Tell your family. Tell your job. You're gonna take the test. All right. So I'll see you soon. Um, good good luck for the test. Have a good test if I don't talk to you, and also have a great weekend this upcoming weekend. Okay, enjoy this beautiful summer. All right. So stop the recording, and if you have any questions, you can stay on the call. See you guys.